Let's solve a challenging problem involving parametric derivatives. We're given two parametric equations x equals 3 at divided by 1 plus t cubed and y equals 3 at squared divided by 1 plus t cubed. We need to find dy dx. To find dy dx, we'll need to use the chain rule formula. Dy dx equals dy dt divided by dx dt. So first, let's find dx dt. To find dx dt, we'll use the quotient rule. Remember, the quotient rule states that the derivative of u over v equals v times the derivative of u minus u times the derivative of v, all over v squared. Let's apply this to dx dt. The numerator derivative is just 3a, and the denominator derivative is 3t squared. Multiplying and simplifying, we get 3a plus 3 at cubed minus 9 at cubed, all over 1 plus t cubed squared. Now, let's find dy dt using the same process. Again, applying the quotient rule, we get 1 plus t cubed times 6 a t minus 3 a t squared times 3t squared, all over 1 plus t cubed squared. Simplifying, this becomes 3 at times 2 minus t cubed over 1 plus t cubed squared. Now we can find dy dx by dividing dy dt by dx dt. When we divide these fractions, the 1 plus t cubed squared terms cancel out, and after simplifying, we get t times 2 minus t cubed over 1 minus 2t cubed. And there we have it. We've found dy dx through a careful application of the chain rule and quotient rule. Notice how all our terms canceled out in the final answer.